Hi everyone, myself Raksha. I'm currently studying in the 8th semester in the Department of Computer Science and Engineering from the college, Sri Venkateshwara College of Engineering. The subject which we are going to discuss today is of the Internet of Things, that is IoT. The topic which we will see today is Raspberry Pi, the hardware layout, operating system, configuration to the programming, wireless monitoring, temperature system. Firstly, we will know what is Raspberry Pi. Raspberry Pi is a single board computer by connecting peripheral like a keyboard, mouse, display to a Raspberry Pi. It will act as a mini personal computer. Raspberry Pi is popularly used for real-time image, video processing, IoT based application and robotic application. Raspberry Pi is slower than a laptop or a desktop, but is still a computer which can provide all the expected features or abilities at low power consumption. It is widely used to make a gaming device, fitness gadgets, weather station, much more. But apart from that, it is used by thousands of people of all age who want to take the first step in computer science. It's also the best-selling British computers, and most of the boards are made in the Sony factory in a pen code or a well. The hardware, now we will see about the hardware layout. Hardware layout of a typical Raspberry Pi board includes various components such as processor. Raspberry Pi model are powered by different processors ranging from the Broadcom BCM 2835 to more recent iterations featuring a ARM based CPU like a BCM 2711. A memory RAM size varies across the different model, typically ranging from 256 MB to 8 GB. Storage: most Raspberry Pi models use micro SD cards for storage. Some modules also support USB storage option. Connectivity: Raspberry Pi board feature built-in Ethernet ports for wired networking and USB ports for connecting peripheral like a keyboard, mice, and external storage device. Wi-Fi and Bluetooth connectivity are also available in certain models. And GPIO, it is commonly known as a general processor input or output. General processor input output pins allow the Raspberry Pi to interface with the various external hardware components and sensors, making it suitable for a wide range of projects. The video output: Raspberry Pi board come with the HDMI port for connecting to display along with the composite video output option. Power: Raspberry Pi border require a stable power supply, typically provided via a micro USB or a USB-C port. Now we can see the what is the operating system used there. We have a few options when it comes to the interacting with the Raspberry Pi. First and most common is to use it like you would mm, you would a full desktop computer. This involves connecting a keyboard, mouse, and a monitor. With this setup, you are likely best served by installing Raspberry uh, Raspberry with desktop, which give you a full graphical user interface to work with. This is a best option if you want an experience similar to working with other operating system such as Windows, Mac OS, or other popular uh, Linux flavor like Ubuntu. The various operating system can be installed on a Raspberry through a SD card. Most use the micro SD slot located on the bottom of the board. The Raspberry Pi primarily based Linux operating system use a Raspbian or a Debian operating system, not a Linux based. The Debian operating system is not the Linux based. It can be used as a RISC OS Pi, FreeBSD, Plan 9 from Bell Labs and Inform, net-based NetBSD, Windows IoT Core on a no-cost edition of a Windows 10 offered by Microsoft that run natively on the Raspberry Pi 2. Operating system uh, based on a Linux. XBN uses the Collide Open Source Digital Center. OpenSure Raspberry Pi Fedora Linux is also used in the Linux based Pi Pedro, another Fedora remix optimized for the Raspberry Pi. Gentoo Linux, Diet Pi, CentOS OS, OpenWrt, Arc OS, Khan OS, NARD SDK. These are the operating system which can be used in the Linux based. Configuration to programming. Raspberry Pi is an amazing single board computer capable of running Linux and a whole host of applications. Python is a beginner friendly programming language that is used in school, web applications, scientific research and many other industry. Raspberry Pi runs Linux and support Python out of the box. Henceforth, you can that sum on a normal any Python program computer. However, it is general purpose input-output capability that is provided by the GPIO pins on a Raspberry or for the IoT that make it useful. Here we can see some example for the Python programming based on the Raspberry Pi. To print the hello world statement, we can directly print by using the print statement, print hello world. To program to add the two number. Here we have taken the two variables a and b with the initialization of the floating number 1.2 and 5.3. To this we have added the sum is equals to float a plus float b. To print this, to get the output, we have used the print statement. In that we have used the sum of and format statement where we get the output a comma b comma sum. And to print the Fibonacci series, a comma b we have initialized with the 0 comma 1, while b is greater than 200 we print 6 other or else a comma b is equals to b comma a plus b. Now we can see the wireless monitoring temperature system. Raspberry Pi, which is having inbuilt Wi-Fi, which makes Raspberry Pi to suitable for a IoT application, so that by using IoT technology, this monitoring system works by uploading the temperature value to the ThingSpeak cloud. By this project, you can able to learn to how to handle cloud-based application using API keys. In this monitoring system, we used ThingSpeak Cloud, the cloud which is suitable to view the sensor log in the form of graph plots. Here we created one field to monitor the temperature value that can be reconfigurable to monitor a number of sensor value in a various field. This basic will teach you how to work with the cloud by using LMS35 value into the cloud. DS18B20 temperature sensor. The DS18B20 is a L-wired programmable temperature sensor for a maximum integrated. It is widely used to measure temperature in a hard environment like in a chemical solution, mines or soil, etc. The construction of the sensor is rugged and also can be purchasable with the waterproof option, making the mounting process easy. It can measure a wide range of temperature from minus 55 degrees Celsius to plus 125 degrees Celsius with a decent accuracy of plus or minus 5 degrees Celsius. Each sensor has a unique address and require only one pin of MCU to transfer data. So it is very good choice for measuring temperature at multiple points without compromising much of the digital pins of the microcontroller. Applications of the wireless temperature control will be the measuring temperature at a hard environment, liquid temperature measurement, applications where a temperature has to be measured at multiple points. This will be the temperature sensor pin out and this will be the temperature sensors diagram. This red wire will be the VCC. Black wire will be connected to the ground. Yellow wire will be the data connection. Similarly, this also. Thank you.